Today, 3.6a. So I showed you this problem at the end of yesterday to kind of preview today. And so I talked about the fact that this is not multiplication, even though the sign is right next to the 2t. That makes it kind of look like multiplication. It's not multiplication. It's 2t plugged into sign. So then what is that called if you have another function plugged into another one? Yeah. It's called a compound function or a composition. Good. So what we're learning today is how to take the derivative of a composition. Okay, so before you try to do that, you have to identify the inside function and the outside function. So on this problem, the inside function, the one that's plugged in, is 2t. Everybody 100% certain with that? Okay, and then the outside one, the one that 2t is plugged into, is the sine of t. Is everybody okay with that? It's a little bit harder. Okay, so we have sine of t, and then 2t is put in place of the t. So then you get the sine of 2t. All right, so that's why this is a composition. Inside function is 2t, outside function sine of t. The way the chain rule works, sorry, I threw in that word. The chain rule is the rule that tells you how to take the derivative of a composition. So we got product rule for taking derivative of products. We've got quotient rule for derivative of things divided. So now today we're going to have chain rule for taking the derivative of a composition. Okay, so it's y prime. So the way it works is you take the derivative of the outside function first. So the outside function is sine. So the derivative of that is cosine. Okay, so the outside function is sine. The derivative of that is cosine. So you take the derivative of the outside. That's the first step. Then you plug the regular inside into it. So you plug 2t into this. So the derivative of sine of t is cosine of t. And then you plug 2t into that, and you get the cosine of 2t. Is everybody good so far? Do I have like something on my nose or what's going on? If something's really funny, it's fine for you to tell me. Okay, all right. So I don't have like kick me sign on my back or something, or because when it makes me feel self-conscious. So plus it's on tape, so I don't want to. Okay, so I'm good.
Yeah.
All right. All right. So if we take the derivative of the outside, and that's cosine, and then you plug the regular inside into it, so that's 2t. And then the third step is to multiply by the derivative of the inside. So you multiply by 2. Okay, so there's 3 steps to the chain rule. So let's write these down. So this is the chain rule. The first step is derivative of outside. So the very first thing you do is you take the derivative of the outside function. Okay, then you plug the regular inside into it. So first step, take the derivative of the outside. Second step, plug the regular inside into it. And then the third step is you multiply by derivative of inside. Okay, so that's what we did. The outside function was sine. The derivative of that was cosine of t. Then we put the 2t into that. So we got cosine of 2t. So that was after step 2. And then the last step was to take the derivative of the 2t, that's 2, and multiply by it. Okay, now there's a lot of brackets here, so sometimes we end up putting the 2 in front and writing it as 2 cosine of 2t. So this is the more accepted way to write this. If you leave the brackets off up here, it kind of looks like maybe the 2t is getting multiplied by 2, and it's not that. It's not the cosine of all of that. It's just the cosine of 2t, and then the 2 multiplied later. So that's why I put the brackets in, to make sure that you knew that that's what it was. But it's more convenient to put the 2 in front, and then you don't have to write the brackets. Okay, so let's try another one. This is h of x equals 3x plus 1 squared. Okay, so probably we're going to use the chain rule on this. But before we know if we're going to use the chain rule, we need to talk about why we're going to use the chain rule. So if we're going to use the chain rule, we need to identify this as a composition. So it is a composition. What's the inside function? Yeah, Stephen. 3x plus 1 is the inside function. Everybody 100% okay with that? Okay, then what's the outside function? Yeah, good. So x squared has 3x plus 1 put into it. And so that's why this is a composition. So sometimes people write off to the side, inside 3x plus 1, outside x squared. Okay, so then when you take the derivative, you've just followed these 3 steps. Since we've identified it as a composition, then we use these 3 steps to figure out the derivative. Okay, so the outside function was x squared. So the first step is to take the derivative of that. So that's 2x, right? So far we've done step 1. Outside function is x squared, derivative is 2x. Then, second step is to plug the regular inside into that. So we have 2x, and we're going to plug 3x plus 1 into that. So that's going to be 2 times 3x plus 1. So if we were going to plug 7 into 2x, that would be 2 times 7. So since we're plugging 3x plus 1 into 2x, that's 2 times 3x plus 1. So far we're done with the first 2 steps. We've taken the derivative of the outside, and we've plugged the inside into it. So now all we have left is multiply by the inside derivative. So the inside is 3x plus 1. The derivative of that is 3. So we just multiply by 3. So then usually we would multiply the 2 times the 3. Final answer would be 6 times 3x plus 1. And you could distribute the 6 also. Yeah?
So if the outside function is x squared, the derivative of that is going to be 2x.
Yes.
So the 3x plus 1 is just the x.
Correct. Because when we plugged the 3x plus 1 into it. Good. Okay, so that's the derivative. Let's try this one. We got the square root of 1 plus 3x. So what is the inside function here? One plus 3x, right? And then what's the outside function? X to the 1/2. Okay, so first of all, it's the square root of x, which is the 1/2 power, right? So outside function is the x to the 1/2 power, and the first step is to take the derivative of that. So that's 1/2 x to the negative 1/2. So let's write that off to the side. So is everybody good with this being the derivative of the outside function? Okay, so that was step 1. Now step 2 is to plug the inside into that. So it's going to be 1/2 times 1 plus 3x to the negative 1/2. So now we're done with step 2. And then the last step is to multiply by the derivative of the inside. So the inside is 0, derivative is 0 plus 3. So you just times by 3. Okay, so now that I've slowed it down some into 3 steps, these 3 steps are important, but what you're going to do after you get good at this is you're going to look at the original function like that. That's still the original, right? And you're just going to do the derivative like normal. You're going to bring the half out front and subtract 1 from the exponent, right? That's the first 2 steps. And then what you're going to forget is you're going to forget to multiply by the derivative of the inside. So the first 2 steps are going to come naturally eventually. But the third step is the one that's going to be forgotten often. So really the thing you want to focus on most is remembering to do this. And then in practical sense, these 2 steps kind of happen naturally. But there's some knowledge there that I have to make sure you know, and that's why I'm breaking it down in that way. Okay, let's do this next. Oh, yes. Bless you. Okay, so we have y equals the sine of x times the tangent of 4x. Okay, so this one is a mixture. Is there a chain rule in this problem? Is there a composition? Why, Elijah? What's being plugged in? Yeah, the tangent of 4x is the composition, right? Here we have 4x plugged into tangent. So when you see that, that tells you you've got chain rule going on because you've got a composition. Okay, but what else is going on in this problem? Multiplication, right? So this is both product rule and chain rule. So we have to decide, is it mainly a product rule and then it's got a little chain rule within it? Or is it mainly a chain rule that has a little bit of a product rule within it? Okay, so it turns out that this problem is mainly product rule. And the reason it's mainly product rule is because the last thing is the multiplication. So if you did this problem with a number, the last thing you would do is you would take that number times that number after you figured out the sine and the tangent. So because the multiplication is last, this is mainly product rule. So this is kind of tricky for people to figure out, so that's why I'm making sure I write it down. This one is mainly a product rule because the multiplication is happening last. Okay, so we're going to use the product rule to figure this derivative out. But then Elijah's right, there's some chain rule going on during that because this is a composition. All right, so the way the product rule works is you take the derivative of the first thing, and the derivative of sine is cosine, times the regular second thing, plus the derivative of the second thing. And I don't want to do that right now, so I'm just going to say, hey, don't forget to take the derivative of the second thing. And then times by the regular first thing. Okay, so all of this that I just did is just the product rule. Derivative of the first thing times the regular second, plus derivative of the second thing times the regular first. So is everybody okay so far with product rule? Okay, now, but I haven't done this derivative yet. So I didn't really take the derivative of the second thing. I just reminded myself, hey, remember, take the derivative of that. So now I need to work on this. Okay, while I do this, this is a chain rule because the inside function is 4x and the outside function is tangent. All right, so while I do this, I'm going to use chain rule. The outside function is tangent. The derivative of that is secant squared. So I have to take the derivative of the outside. And the outside is tangent of x, so the derivative is secant squared of x. But then the second step is to plug the 4x into that. So it's going to be secant squared of 4x. So far I've done the first two steps. I took the derivative of the outside, that's secant squared, and I plugged the regular inside into it. And then what do I have to do last? Multiply by the inside derivative. So the inside function is 4x. Derivative of that is 4. So I have to multiply by 4. And it doesn't matter if you times at the end or times at the beginning. However, if you put the times 4 here, it kind of looks like it's being multiplied by the 4x. So that's why I like to put it at the beginning, so it's clear that it's multiplied by the answer to the secant. So then I just recopy everything else, the sine of x and the plus and the cosine of x and the tangent of 4x. Okay, how about y equals 2x over sine of x to the third power. So what rules are going to happen in this problem? Quotient rule is going to happen, right, because there's division in there. And also chain rule, and the reason chain rule is going to happen is because a mess is being cubed. So the outside function is x cubed. Okay, so what's happening last? Is the division happening last, or is the cubing happening last? Cubing's happening last, so that means that this problem is mainly a chain rule, and then it's got quotient rule on the side. So over here, the multiplication was last. That's why it was mainly product rule. But here, the cubing is happening last, and that's why it's mainly chain rule. Okay, so when you take the derivative, the outside function is x cubed. And the first step in the chain rule is to take the derivative of that outside function. That's 3x squared. Okay, so the first step is outside function x cubed, derivative is 3x squared. Now I have to take the inside function, which is this whole mess, and plug it into 3x squared. So that's going to be 3 times that squared. So what goes inside is the regular inside. So this looks this looks natural to people. You just move the 3 out front and subtract 1 from the exponent, right? That was the first 2 steps. Okay, then to finish it out, though, this is what people forget. They forget the times by the derivative of the inside. And when we do the derivative of this inside, it's a quotient rule. So you have to take the derivative of the top times the regular bottom minus the derivative of the bottom times the regular top, and then all over the bottom squared. And you could do some simplifying, but it's not necessary every time. So I'm just going to leave it like that, especially since it's a Wednesday. Is everybody okay with how I got here, though? Yes?
Explain how you knew you were going to use the chain rule.
Because I had a mess cubed. And so because of that, something is plugged into x cubed. And that means it's a composition. And anytime you have a composition, it's a chain rule. So here, I knew I needed chain rule because I had tangent of a mess. And so something was plugged into tangent. So that was a composition. Good, so Bailey's hitting at the central question, right? Later on, all the problems will be mixed up. So today we're using chain rule every time. So it's a really valid question to say, why do we know to use chain rule? And so whenever you have a composition, that's when you use chain rule. Okay, so I wrote down the chain rule in an informal way. So in order to get to the formal definition of chain rule, I'm going to look at these functions. So we've got f of x equals the square root of x and g of x equals x to the 4th. And for part A, we're going to find f of g of x and f of g prime of x. Okay, yes.
Is the f of g of x, is that just the f inside, or g inside of that?
Yes, so Brandon is telling us that this means this. Good. So this is a composition because it's got g of x plugged into f. All right, so in order to figure out that function, I need to take this x to the 4th. So g of x is x to the 4th. So I need to take this x to the 4th and plug it into f. And f takes the square root of whatever. So that means I need to take the square root of x to the 4th. And the square root of x to the 4th is x squared. So the problem asked me to figure out f of g of x, and I just did that. The answer is x squared. Okay, now here it tells me to take the derivative of that brand new function that I just created. It says take the derivative of the f of g function. So f of g prime is just 2x. Okay, so I'm setting up notation so that I can write down the chain rule in a formal way. Okay, so now for part B, we're going to calculate f of g prime at 2. So here I figured out what f of g prime was, right? So now I just need to plug 2 into it. So that's 2 times 2, which is 4. So all I did was take that 2 and plug it into this function I figured out from before. Okay, then for C, I'm going to find f prime of g of x and f prime of g of 2. Okay, so here this says plug g of x, which is x to the 4th, into f prime. So if I'm going to do that, I have to go off to the side and figure out what f prime is. So my f of x is square root of x, so that means my f prime is 1/2 x to the negative 1/2. So this is my original f of x. That, another way to write square root is 1/2 power, right? So the derivative is 1/2 x to the negative 1/2. Okay, so now, you good, Brandon? You're frowning a little bit.
I thought we took so if it's like x to the 4th, that we took 4x to the 3rd.
Yes.
So we're
So square root of x can be written as x to the 1/2, first of all, right? So I did the same thing. I brought the half out front, subtracted 1 from a half. So just like here, you subtract 1 from 4 to get 3, so you subtract 1 from a half and you get negative half. Good. No, that's good. Yeah.
So since the tick mark is after F, rather than that G, and
It means just take the derivative of f. So that's why I went over here to do that.
So what's the difference between taking the derivative of f of g with x?
Like, basically you're saying, how would I write?
I'm just wondering, like, difference in months, because, like, we did parts A and B.
Yeah, this right here says take the derivative of this composition function. So I found the composition function, and then I took the derivative of it to answer that question. This just says take the derivative of the regular old f function and plug g of x into it. Okay, so that's why I went off to the side and took the derivative of f. And now I'm going to plug the x to the 4th into that. So that's 1/2 times x to the 4th to the negative half. So then I need to take the square root of x to the 4th, because that's what the half power means. So that's x squared. And then the negative means take the reciprocal of it. So that's 1 over x squared. So I'm ignoring the half for right now. So I took the square root of x to the 4th, and that's x squared. And then the negative means take the reciprocal. So then if I multiply that by a half, my answer would be 1 over 2x squared. Okay, so now I've got to plug 2 into that. So I've got f prime of g of 2. So g of 2 is 2 to the 4th, which is 16. And then that tells me to plug 16 into f prime. So here I've got 16 to the 1/2, which is 4. Because the 16 square rooted is 4. Then that negative means 1/4. So I've got 1/2 times 1/4, which is 1/8. Okay, now D is going to say, find G prime at 2. Okay, so G prime is 4x cubed. Yes?
I don't know if you're not on, so can you just put 2 into that formula
Sure.
knowledge to?
Yeah, if you put a 2 there, you get 4, and then it's 1/8.
Okay.
Yes. Yeah, it's the same thing. Good, yes, nice. So G prime is 4x cubed. Then you plug 2 into that, and you get 4 times 2 cubed. 2 cubed is 8. So that's 4 times 8, which is 32. Okay, so now we're going to figure out f prime of g of 2 times g prime at 2. G prime at 2 was 32. So I'm just taking my answer that I got from before. And then f prime at g of 2 was 1/8. And then 1/8 times 32 is 4. And so what I'm trying to show is that that 4 matches up with this 4. Okay, so if you take the derivative of the composition, the way you do it is you take f prime of g of 2 and multiply by g prime of 2. So I'm just trying to get you used to this weird mathematical notation, right? So all I'm saying is the answer for part B equals the answer for part E. Okay, so then the chain rule says that if you have a composition, that's what that is, right? If you have f of g, and you want to take the derivative of that, so to take the derivative of the composition, what you do is you take the derivative of the outside function in this case is f, right? So you take the derivative of the outside, plug the regular inside into it, and then multiply by the derivative of the inside. So to me, this says the 3 steps that I wrote out earlier, but it's written in notation that's harder to understand. All right, thank you for listening. I appreciate it.